Hello, and thanks for joining tonight's TI Technology webinar hosted by Texas Instruments, where tonight we're really excited to share some information and activities to be used with our new TI-Innovator Rover. My name is Mike Houston, and I'm the moderator for this event. I teach algebra and calculus near Pittsburgh, where I use TI technology to make tough-to-teach, tough-to-learn concepts accessible to all my students. I'm really excited to introduce our two panelists for tonight, Becky Beyer and Curtis Brown. Becky is a nationally board-certified teacher who teaches grades 9 through 12. Her current classes at Kelly Walsh High School include pre-algebra, Algebra 1, Algebra 2, and AP Statistics. Becky has also taught Visual Basic Programming. Becky has a bachelor's degree in mathematics education from Black Hills State University and a master's degree in mathematics education from Montana State University. Becky, thanks so much for being with us tonight.
Thanks for having me, Michael. I'm excited to share a little programming with everyone tonight. Should be fun.
Absolutely. And Curtis is the market segment manager for the mathematics education market at Texas Instruments. He is heading up the development of content-based math programs such as the Building Concepts and Activities in the STEM Behind series. Curtis was an AP statistics teacher himself, as well as Algebra 2 teacher in Houston, and worked as a statistics content specialist at the National Math and Science Initiative. Curtis, thanks for being with us tonight.
Pleasure to be here. It should be a lot of fun tonight.
We're expecting a large crowd, so your audio is muted. Feel free at any time to send any questions to Curtis or Becky using the Q&A window on the right side of your screen. As a reminder, this session is being recorded, and we'll provide a link to the event certificate of attendance at the conclusion of the webinar. We hope you don't have any audio issues tonight, but in the event that you do, try selecting Communicate in the top WebEx menu and choose Audio Broadcast. If that doesn't work, look in the participant window where your name is located. In that window, in the lower portion of that window, there's a little phone icon, and if you click that phone icon, you'll be given information to call in using your phone, and that should eliminate any potential audio issues. At this point, Becky is going to discuss our agenda.
All right, so the first thing we're going to do is our welcome and introductions. We've already done that. The next thing, we're going to share some ideas for coding in the math classroom. Some of the activities we're going to share tonight I've done with classes, with my pre-algebra classes. Some of them I've done all the way up through my Algebra 2 classes. And then we are going to share with you some coding activities with the new TI-Innovator Rover that you could use with your classes. We'll take a look at some online resources to provide you with some further steps to go in your coding endeavors. And then we're going to talk about how you could win registration for two to the international conference that's coming up this March in San Antonio.
Thanks, Becky. And Curtis is going to discuss our expected outcomes.
All right, so tonight we're going to look at exploring the basic programming in the context of engineering design. Intended to improve students' computational thinking in their math classes. And then we're going to look at connecting learning across science, technology, engineering, and math. Looking at function transformations. I'm really excited about this particular connection that we're going to look at tonight. And finally, we're going to look at creating some STEM experiences that hopefully are pretty engaging for students to develop their abilities to collaborate, think creatively, solve problems, and just explore mathematics with the TI-Innovator Rover.
Thanks so much, Curtis. Becky, it's all yours. Feel free to share your screen.
All right, so, sorry, clicked the wrong button. All right, there we go. So the first thing we're going to take a look at tonight is how to find the slope between 2 points. It's a big concept. I know my pre-algebra students, I've done this activity with them. My Algebra 2 students have just finished up a review unit on how to find the slope between, or a linear equation unit, and so slope is a big concept for them. This is definitely something my Algebra 2 students felt this semester was, oh my goodness, I've done slope like the last 4 years in a row. But by coding it on the calculator while we were reviewing it, the kids got really engaged, and they're like, oh my goodness, this makes sense. Some of my students who accidentally would flip the numerator and the denominator when solving for slope between 2 points after coding it didn't make that mistake anymore, and they loved it as a check tool. So as they were doing their homework, they could plug it in and check it, and they'd be like, oh my goodness, now I finally, you know, kind of have that computation down packed. So what you see on my screen right now is the lines of code to write the program. So anytime you find the slope between 2 points, you're going to have 2 x values and 2 y values. So those first 4 lines are just asking the student to enter them. Then we're going to calculate the denominator. And then if the denominator is 0, it will show that it's undefined. If it's not undefined, then we go ahead and find the numerator. So I'm going to go ahead and show you what it looks like, and then I'm going to show you some of the menu controls to go ahead and code that. So I'm going to hit the variable key because my program is actually stored right in there. And I'm going to say I want to run my slope program. So let's say my x value is 2, my y value is 10, and x value is 6. The y value that's paired with that is 12. It'll go ahead and simplify it out, and it will show that my slope is 1/2. To code this program, it's fairly simple to walk through with students. All you do is start with a new document. You say, I want to start with a calculator page, and then you go to Menu, Functions and Programs, and you tell them you want to do a new project, and then you just give it a name. I might call it Slope 2 because I already have one running. So to begin with, it has a split screen for your students. The screen on the left is the actual running code. That's my calculator page. The screen on the right is where we're going to code it. So if you ask your students, if I'm going to ask you to find the slope between 2 points, what's the first thing I as a teacher have to tell you, the student? And the kids will be like, well, I need to know what the points are. Well, so does your program. So all I'm going to do is go to my menu, and everything is menu driven. So even if you're not a coder, you just hit the menu button and you walk through them with your kids. So you say, what do I want to have happen? Sometimes the kids will say it's an action. And so you open it up and you go through the menu and you say to any of those actions, actually say, hey, I'm going to give you 2 points. And so I just kind of let the kids go and I say, I want you to find a menu that looks like I'm going to get something from the user. And inevitably, a kid's going to come down to this input-output menu and say, hey, I see something that says request. Request kind of sounds like I want to get something from the user. So we request a value, and then you go ahead and tell it what you're going to call it. And then we would just go to the next line, and we're going to do that for 4 different requests. At this point, I stop with my kids because it's usually the first project I've done, and I want to make sure everybody's at the same standpoint. This little star icon in the upper right-hand corner says it has not built the program yet. It's not compiled. There is a menu for that will say compile, or you can do a shortcut key, which is Control-B. My students like that Control-B feature because to them it makes sense we're building a project. And all that says is my program is stored. So now I can click to the calculator page, and I can say I have a program called Slope 2, and it prompts my user for the very first value. So we've only asked them for 1. Programming with my kids, if I pop back over to my code, programming with my kids, they're going to have to actually enter that in 4 times. So once we have that calculated, then I just kind of walk my students through what kind of calculations are we going to do. So we're going to calculate that denominator. And then this if-then portion, some of your students might have programmed in the past. I'm finding that more of my students that come in have done some sort of an online something or another, and so they might actually know a little bit more about ifs than you think. And so a lot of my kids will say, I'm looking for an if statement. And again, I just turn them loose in the menu and I say, okay, find something that says if. Sometimes they'll notice that right off to the right for that number 4, it does say there's an if statement in there. And it will give you the different types of if statements you want. In this case, we just want to know, does our denominator equal 0? And if so, perform an action. Otherwise, do something else. You can actually write this whole project with your students in probably about 15 minutes. It does take a little longer the first couple times that you've done a project with your kids, but they will be glued to this activity and they will start asking more and more times, can we write a program for that? Can we write a program for that? And I find that the more programs I write with my math students, the more they start to think sequentially and they start thinking, what do I need to make that calculation and how does it go together? And it almost becomes like second nature to them.
That's one of the things that I love about what you're doing here, Becky, is that students really are thinking forwardly. And when I've done this with kids, I've typically left out that if denominator equals 0 piece, and let them kind of play with that. You know, just go ahead and do the math first. So calculate your numerator, your denominator, do the division, and then when they get an error, let them kind of figure out, oh wait, what do I need to do with that? What do I need to display, and what conditions are causing that? So I love that you've got this kind of built together here. This is cool.
The one thing that I would notice is I type a whole lot faster on my computer than my students do. So I find that when I'm coding with kids, that slow down and process piece takes a little bit longer than you would think. If you're really good at programming, if you're just new to programming, it still takes them a little bit longer to find. But I think that payoff is huge. So usually the slope one is the first one I do with my students. Algebra 2 is my constant class that I teach all the time. And it's one of the units that we start off at the very beginning of the our second unit that we do deals with quadratic formula. And this one's actually a great project to kind of really start thinking about what does it mean to have a unique solution? What does it mean to have no solutions? What does it mean to have, you know, 2 solutions? What goes into that discriminant? And so the code for this one, you're going to notice is kind of similar. I'm still going to request 3 inputs, so that command doesn't change. I need an A, B, and C. But my students in the past made a really good recommendation. They don't like to know just what's A, B, and C. They kind of want to know how that goes together with their equation, which I thought was beautiful for my students to be asking. And so they actually had me add a little line at the beginning to remind them, what does the A represent, what's the B represent, what's the C represent? Because really you could put any letter you wanted in there, you know, as long as you use the formula correctly. So this line right here could actually be omitted. That was enhanced by one of my students a couple years ago. It's just going to display the formula form. And then this line of code right here is going to calculate the discriminant. We've already done an if statement for if the slope equals 0, you have an undefined line. Now it's going to be if your discriminant is less than 0, tell the student there's no real solutions. Otherwise, you don't even really need the section where if the discriminant is 0, you just have a double root. That was kind of an enhancement with my students. They wanted to do another if-then statement and kind of make it a little more pretty is what they called it. And then they have their R1, R2 here. So I'll just kind of show you what that one looks like when we run it. So if I go to quadratic formula and I have an A value of 1, a B value of 5, and these numbers are popping in because it was what we were doing earlier in class today with a 6, it will give them the x-intercepts right there. So they kind of, it's a nice little reminder of the students, what's the quadratic equation look like? and then it follows through. An enhancement that I've asked my students to do on their own is how could you modify the code so if the solutions aren't real, it would actually display the imaginary numbers for you. And that's a perfect discussion when you want to talk about kids being a little resourceful, because I had kids Googling, what does it mean to be imaginary numbers? What does it mean to be able to break those apart? And so your students can actually come in here and modify this so that it will actually give them those complex answers. I've even had some students who weren't satisfied down here, and you can like Google, how do I make it do a pretty print? So if my root is 5 plus or minus the square root of 3/2, how do I get it to display a non-decimal? Those are usually discussions that I have with my kids, and I let them go explore that on their own. And then they'll come back to class and they'll be so excited because they'll say, hey, did you know it takes 2 lines? And then it will round your answers to 2 decimal places, and it doesn't go on forever. And I just put a little line that says, you know, answers might be rounded. So this quadratic formula one is pretty nice to do with kids because I've found a lot of my students will go do some research on their own to kind of enhance this basic program so that when they run it, it doesn't just give them answers like no real solutions. Which I don't know, I kind of feel like as a teacher, isn't that, you know, ultimately what you'd like is when students don't know how to do something that you provided them some tools and they want to go research more to get, you know, more involved with what you're doing.
I think one of the advantages of what you're doing here, Becky, and I'll let you get started again on your next one here in just a second, but you know, you made a comment at the very beginning that students, as they do this more and more, it becomes kind of second nature for them to think, you know, consequentially. So if we need these things, what do we need to do, and what's the result going to be if I do this kind of thing? I think that's really important. I've played with a phrase for a long time that if they can code it, then they know it. So it's really nice reinforcement what you're showing here for students as they explore the quadratic formula or some of these other things. I think that's really nice.
So the next one that we usually do is just a simple area calculation. And this one, I kind of let the students choose what are some of the area calculations that you want to put in there. Quite often the kids want to talk about the area of a circle, or they want to talk about the area of a triangle. And so we kind of make a list of all of the area formulas they've got floating around in their head for different shapes. And then usually I assign this one to them as a warm-up because we've done a couple of projects that really will just let you pick the area of the shape you're looking for. So if you notice on this one right here, the students this morning wanted to know the area of a rectangle, a circle, or a triangle. So each one of those is going to have a different formula. So maybe I want to find the area for a circle. And so you type in your radius, and it will tell me with a radius of 3, my area is 9 pi. So I must be in cast mode. If I'm not on a cast, it will actually give me a decimal approximation. Just kind of depends on which calculator you're using with your students. Maybe I want to find the area of a triangle. So I type in the length, I type in the width, and again, it'll give me their area. What's nice when you assign this to your students is they're generating the shapes that they're looking for, but quite often my kids will have to look them up. Trapezoid is another one that comes up quite often that the kids are like, oh, I always forget how to find the area of a trapezoid. So they'll start Googling it, whether it's on their phone or on their laptop. And so then when they get to their code, each one of the students might have a different table here of which options they want to choose. But then you're going to use the same code that we've done for the other two projects. They're going to have to request which object are you looking for, and then you're just going and using some if statements. If it's number 1, so in this case a rectangle, I know I'm going to need a length and a width, and then I'm going to calculate it. If it's a radius for a circle, or if it's going to be a length, then you just keep adding in more else-if statements. And so some of my kids might actually end up having 8, 9, or 10 different questions that are in here. I've done this with volume before too, where they're going to find volumes of cylinders versus volumes of prisms and talking about the kind of prisms that they're finding, and then ultimately displaying their area. So this one is really a nice open-ended problem, or you can walk through it with your students. When I taught pre-algebra, this one usually we wrote at the end of our area unit. We would take everything that we had done, and then we would put that into a menu, and that was their project, was could they code all of them. So last but not least, I want to talk about wind chill. This was probably the most engaging activity I did last year. Depending where you live, we get snow all the time, and the kids will walk in and they'll be like, oh my goodness, it was a -20 outside with wind chills. And I tell them once you get past, 20 degrees, it's cold. But what does that wind chill mean? And a lot of the kids will be like, well, I don't know. I know outside if it's 30, but the wind is blowing, it makes it colder. And so we did a little research last year to see what does that equation actually look like. So we Googled it, and so we found it off the internet. And it turns out it's a great extension of exponents to get that equation in there. So this one was really short. It didn't even involve an if-then statement. The students just need to know what's the temperature outside in Fahrenheit, what's the speed, and then they plugged it into the formula that they found online, and then it tells you what the feels like is. Then to check it out, we just had a couple of kids hop on either to the internet or to their phones and run a weather app and see what was the temperature, the wind speed, and what does it say it feels like. And the kids were so cute because they were making comments like, oh my goodness, in the morning, if I want to know what it's like outside, I could just use my calculator. And then they're giggling going, oh wait, you still need to know those 2 inputs. But they knew where the formula was coming from, and they didn't say, when am I ever going to use exponential equations? Because here was a real life example, and quite often my kids are checking their phones to see how cold it is outside when, the wind is blowing and there's snow outside. But it was also a really nice extension to talk about domain and range, as when does this function not make sense anymore? Like, can you type in any Fahrenheit temperature and any wind speed, and is it always accurate? And again, we didn't know the answers to that, so we started Googling to try to find out what are the parameters that make this equation a good approximation for what the wind chill is. So it was a really nice real-life extension that wasn't contrived, that was very student-driven, that the kids were hitting different websites and saying, well, according to this website, it says this. Well, according to this website, it said that. So it was just awe-inspiring to see how involved the kids got with this little short 4-line chunk of code, but something that was very relevant to their everyday life.
Hey, Becky.
Uh-huh.
We had a question from Christina, and her question is, should we be concerned about units here, or at least some sort of discussion? Is it possible to include units in a program?
So by unit, do you mean like the rounding that's going on? Trying to see how to get to the chat window.
It was in the Q&A.
Oh, Q&A window. So I know that for units in here, you can actually add the degrees back on the back. So right now, like the one I ran this morning, I just typed in 30 degrees Fahrenheit and 20 degrees miles per hour. I didn't label the feels like. It's really quick to just add a comma at the end, and then you can go add in your degrees Fahrenheit. I'm not sure if that was what the question was asking, and run it, and it will put that in there. You can talk about rounding. I don't know if that answers the question with units.
I'm not sure.
What do you think,
I know Paulette mentioned that she'd be interested in doing something like this because she lives in Texas, and so maybe instead of how cold things get, maybe about the heat index.
I did look up the heat index.
I think there's some really great Sorry, Becky. I think there's some really great exploration certainly to be done here too in terms of heat index or the wind chill. I know in Texas we probably are more interested in probably the heat index during the summertime, but I think also just the same conditionals that you were showing just a minute ago with the if statements, like this program could be extended to say, okay, well, you know, what happens if the temperature is above a certain amount? What's the change in that formula? What do we need to do differently, and how do we set up the conditionals to kind of deal with that?
It was also interesting when we researched this that I know that they had two different formulas online, and they said the original wind chill speed was this, or wind chill formula was this, and then it was changed to the new formula that I have there. So some of my kids even started comparing them. How are they the same and how are they different? And we plugged in different degrees for Fahrenheit and miles per hour to see what were those two models predicting. But I do know there was a heat index when I looked earlier tonight. I just didn't include that in the slide.
That would be really interesting to do, and then to push those out to a function and look at those on a graph screen and see how they change in reasonable domain and ranges. I think that would be kind of a fun project to compare the two different wind chill formulas as well.
We even said one extension that might be nice. We have some temperature probes, or we have some of the TI-Innovator hubs, would be to modify it so that you could walk outside with your calculator and get the actual temperature for your school, not just, you know, what it says on your weather app, because depending on where that weather app was taken, your temperature is going to be a little bit different. So you could even do some real life stuff of, okay, so what's the temperature outside the door on this building versus in the shade, you know, and just kind of talk about standing in the shade temperature versus standing out in the sun temperature. What's the difference on a nice sunny day?
Right. Right, I think that's really good.
That, I think, Curtis, I'm ready to pass the ball your direction.
Okay, that sounds great. All right, Becky, let's see, did you give me the, okay.
I think I have passed you.
I am now in charge, watch out world. Let's see. There we go. Now I'm up. Annotation request. Let's do that. Okay. So when I started thinking about this webinar and kind of the topic here and what sorts of things I might want to share, I liked all the things there that Becky showed, and I think we have some. I made analogous versions of those programs. For example, I made the area program. It looks basically the same on 84CE and inserted these. So I'll share all of those at the end of this webinar. We'll make sure that those are sent out with the follow-up email. I think I didn't get them into Mike early enough, so they're not available currently, but they will be available at the follow-up email. But I started thinking about this webinar and kind of this topic this summer when I was writing a program for one of our TI Tip Tuesdays for the 4th of July. And I was making this animation that we promoted and we put out on the website for the 4th of July. We've got a few fireworks kind of displaying on the screen, and I was thinking through, how do I make a firework? How do I draw a firework on the screen of the TI-84 plus CE? And then as I was thinking about what fireworks look like, I thought, well, gosh, there's some nice functions that could be mirrored here, and so I started thinking about, well, my favorite function that could maybe be turned into a firework is a square root function. So I said, okay, well, let's start looking at a square root function. And I know that in traditional kind of draw programs that students do on their graphing calculators. Often those programs are in the form of some sort of a piecewise function or things where students have to really worry about the limits, and the focus is primarily on defining piecewise functions and making things work from in certain X units. In this version of this, or at least the way that I was trying to do this, I was really trying to draw this from more of like a points place. And so I started thinking about transformations of functions, and I don't know about you, but when I started teaching transformations of functions to my Algebra 2 students, and we started, making these families of function, we started with the points themselves in some sort of a T-table and kind of relating those across the T-table, and then trying to relate those to the graph screen and what happened when I translated, if I did a translation of f of x is x minus 4, and then I do g of x is g of x minus 4, and what does that do translating right and left and up and down, and how do those kind of translate to the graph of each of those two functions. And so I started thinking about how that might apply here in this situation and how to actually make this happen. And so many of you may be familiar with drawing on the screen, being able to turn on a point on the screen, but so when I did this, I started playing with it. I set up my graphing window such that every pixel was a point in the positive, in the first quadrant. So I set up the window to be set just 264 by 164, and that way all I had to do was think about the x and y values. I didn't have to try to translate pixels and things. But when I was playing with this, I realized, hey, I'm doing a transformations of functions lesson here. Everything is all transformations of functions because I'm dealing exactly in my x values are those first units. So all of my x values are the first units in those point on commands, and then all of my y values, my functions, my square root functions here, are corresponding to my y values in the function. So I first of all had to think about, okay, so where do I want these fireworks to start on the screen? And so I started, playing with that value and translating my fireworks display up and down on the screen and trying to match those values up and figuring out what looked reasonable on the screen. And then second, I started, I started with just square root of n, honestly, and I started playing with the transformation to try to do a little bit of vertical transformation there. So you'll see that I'm taking the square root of 9n and trying to correlate that transformation to the horizontal translation of this function. And so I'm going to kind of put this on the side here and try to show both of these at the same time so you can see the picture. Let's see if I can do this well. And the oh man, I had this set up earlier and I'm not doing a very good job of it now. Dang it. Okay, here we go. Now I've got them kind of set up side by side where you can see the code and the picture at the same time. There we go. Now I got it set up. So if you look really carefully, you can see I've got this thing translated so that the red version is the highest value, which is this one that starts at 120, and then each of the square root functions, so first the 9n, and then the 25n, and the 49n. By the way, I did the math so that it was easy for me to kind of play with there. But I was able to kind of translate the widest version of that, the 9n, and then kind of skinny it up just a little bit and figure out what kind of transformation I wanted to do such that firework would look kind of symmetric and centered in the right places. And you'll notice I've got the reflections in here, building this, so plus and minus, working in the x direction on each side. So it was really kind of a fun little transformations of functions exercise. And I think, getting the students to work on and think about transformations of functions in that way, this was a nice little exercise in applying a family of functions there. So this is one way to kind of grab students or get them thinking about mathematics along with doing some kind of more interesting kind of coding application, like, hey, I want to draw a picture and see how I can make that picture happen based on transformations of functions and using some of the for loops and statements of that nature to try to iterate through kind of a set of functions. So that was kind of an interesting project that I had going on, trying to display something cool for the 4th of July. Now, one of the things that we have just released and we're really, really excited about here at TI, and I know Becky, you're gonna kind of talk to some of this as well. Is the TI-Innovator Rover, and so we just made a really great big launch for this on our website, and we had a great public launch for this. We're really excited as this extension to the Innovator project. As an extension to the Innovator project and plugging and coding in our STEM solution, I think this is a really nice piece to it. So I'll kind of walk through just briefly a couple of things. This will be available mid-October. We made our public launch of the project itself a couple weeks ago, but now it'll be available in mid-October. I'm trying to get my slides to go. So a few of the quick features, then I'm going to walk through a couple of ideas. So we are planning to have a marker for the rover, just so that you can draw paths and kind of animate some things, and I'll show you some pictures of or some rover drawing this evening, some pictures of the way that it could do that. And then there's the motion sensor on the front, color sensor on the bottom of it, so that you can actually sense driving over particular colors. And then it is working off of a rechargeable battery, as well as having the Grove input sensors. I know that Becky made mention of doing some data collection, and so this is one of the places that you could potentially do that, although I haven't tried doing that yet, but it is available. So we have a series of activities that we're going to be going live with. The first in that series is called the Math in Motion series. It's called Design a Path, and we're planning to have students be able to measure out and design a path that then they can program Rover to drive. And so this will be using the TI-Innovator commands for Rover and having some interaction with the Rover and some of those drive commands. So I want to give you, first off, just a video demonstration of what that might look like, and then we can kind of look at some of the code or some of the things there. And Becky, I'll have you kind of walk us through some of the way that you could prompt for those things. So first of all, let me show just a video of the way this might look. So here's my little rover in the math classroom here at TI, driving a path that I predetermined and gave it the commands to drive. One of the really fun things that is cool about that, and we've seen students really get excited about here, is this is a really great investigation into how do I get Rover to make this turn here, and what angle am I actually interested in? Because every time I've done this with students, the first angle they want to measure is an interior angle. And if you kind of put yourself in the driver's seat of a car, or you think about, okay, I'm driving and I need to go this direction, or I'm walking and I need to navigate some direction, I'm following a path, the angle that you turn is never an interior angle. It is always an exterior angle, and so there's this really nice interaction that students, the first time they do this and they're prompted for what angle do you want to turn, they drive the wrong angle, and so it's kind of fun to get them kind of oh, okay, so that's what an exterior angle is, and that's kind of one of the purposes of pieces of exterior angle. So I think this is going to be a really nice way to kind of get things going. So Becky, I'm gonna pull up the Nspire here, and I'm going to just insert a new program page. And you can kind of show us a little bit maybe of how easy it is to kind of make a rover program. Does that sound like a fair plan here?
Yes, that does.
Okay, so I'm going to pull up I'm going to pull this up and let you talk to us about how to make this program go.
And Curtis, while you're bringing that up, we had a question whether the wheels can be programmed to operate at different speeds independently of each other.
So the answer to that question, I didn't see it pop up, but I'll answer that question right away. The answer to that question is yes. As a matter of fact, we can integrate that real easy into our little demonstration here of how to kind of make maybe rover drive something.
So I've only played with the rover for about a week this summer, so I'm going off memory, and then I played a little bit the other day because you can download the new update. It's really quite almost intuitive to run it. It runs off the hub. So if you'll notice, he went to menu, and then it goes to a hub option. And then from there, notice there's this new icon that says rover. If you haven't updated your teacher software to the new 4.5 software, you won't see rover there, so you'll need to actually go do that update. But now you're just going to ask yourself, what do I want rover to do? So notice you have a bunch of different options there.
Sorry.
That's okay. You just lost my
Let me do that again here.
So if you go to menu and then you go to rover and then you ask yourself, okay, what is it that you want rover to do? Well, let's go look at the very first option. So if we go look at that first window, oh, maybe you want it to go forward. So we'll choose number 1 for forward. And then you just have to tell it how far you want it to go. This is a great conversation. I love the fact that it's in meters, because if I want my students to go, let's say 12 centimeters, they have to have this conversation as to how do I change it into meters. But now my rover is going to go forward for a meter. And then maybe I want it to rotate. So Curtis is going to insert a new line there. I'm going to go right back to the same menu, and it's a hub, and it's rover. And then I'm going to go back to that number 1 for drive, and what do I want it to do? Well, let's make it go left. And then you insert your number of degrees. So he's got a 24. And then remind me, Curtis, do I have to have a degree symbol in there? Oh, it's the word degrees. Thank you.
So the rover itself is in degrees, so if I left off that statement, it would function. So 24 would be assumed. If I wanted to do this in radians for some reason, I could type in a radian measure, or I could give it the radian command. But yeah, it's always in degrees, or the default is in degrees.
And so what's nice is you could check that out right there. I do know when I worked with students, that you have to make sure the rover is turned on. And I know that my students quite often when they went to run their program, they'd have that, they wanted to trace it with a marker, so they would turn their rover off to flip it over and take the cap off their marker, or to move that marker around. And so the number 1 issue that I saw with kids wasn't the coding. Coding was easy, was did you make sure to turn your rover on before you try to send the command. So there is a way to go ahead and say, connect to my rover, which Curtis and I kind of jumped over, but I wanted to show you how easy it is to tell it to go forward and to rotate, is to just go back up and insert 1 line that says connect my calculator to the rover.
Oops, let me do that again. I saw a question there.
And then we have a question. I just saw that question pop up too. So if we go to rover And then notice if I look for connect is what I know I'm looking for, it's option number 8. So Timothy just asked a question about, I don't know where that just went. Can multiple kids use the same rover? I know I'm planning on using it with a classroom full of 30, and I won't have 30 rovers in my classroom. So it would be really easy to group your students up into groups of 3 or 4 and have them code once on a calculator at install. Or Curtis, can you flip back to your video for a second?
Sure, I can do that. Let me do this here.
I also can envision if I wanted my students to do something like this, if you'll notice on his calculator itself, it's just held in by 4 little pins that are really easy to, you flip them and your calculator slides right out. All you do to get your calculator in there is stick it on the top, hold it with those 4 little pins, and then you plug in your calculator to the rover. So I could also see having my students code it and then sharing multiple rovers so they can actually run their own code. So I could see working small groups or kids checking their own.
Right, yeah, so Timothy, every time we've done this with students, we've actually had a really, nice way to work with students. Like it really teaches them a little bit about what it is really like in engineering and sometimes in a laboratory where multiple folks need to use a certain piece of equipment and they have to kind of schedule themselves. This works kind of the same way, right? They're writing code on their own on their calculator, and everybody's got their own calculator, but maybe only 2 of them, maybe there's like a rover for every 2 kids. And so it works out really nice to have students, flip-flop back and forth, and they have some nice interaction and discussion, not only about what they expect their program to do, but some of that how-to engagement too, right? So one of the challenges that I like doing with students is asking students to maybe make rover drive a square, but change the speed so that it doesn't drive the same speed on every side. And so they have to do some of that distance, rate, and time kind of calculations and changing the speed and changing the distance that it drives or changing the time that it drives at a certain distance, at a certain speed so that it comes out to be a certain distance. So that's a really nice project, a really nice challenge that students can kind of talk through back and forth and write completely different programs to drive the exact same thing. And so that's kind of a fun way to work at it. Let me show one other thing, and then I want to get kind of give command back to Mike. So Mike, I want to demonstrate one more thing that we're planning to do with Rover and release this fall in another activity, and that is, let me pop this back up here. Oops, wrong one. This one. So another classic problem that can happen, and it's an Algebra 1 question all the time. Please ignore the typo at the bottom of the page there. It says geometry and pre-algebra. This is really, that was a copy-paste error, so I apologize for that. I should have edited these. So this is a 2 rovers leave the station kind of concept, so solving systems of linear equations. And in this case, students are going to use time as the independent variable and the distance from a certain point on a horizontal line as the dependent variable. Speed is going to be slope, and the starting distance from that origin will be the intercept. So this is a really, really nice conversation, a really great way to bring kind of to life that whole concept. And I apologize for this being sideways. I didn't edit this well enough. So look at that system of equations kind of in the middle of my screen there, where I've got position as the y-axis kind of running here this direction, and then time running this direction. So I'm solving a system of linear equations. It just so happens that intersection happens at time 4 seconds and at distance 4 units from this kind of origin on a horizontal line. So we're really putting this in traditional solving systems of equations kind of thing into a real life concept and actually having it at work. And this 4 seconds to intersection and crash. Kids love crashing things together. It's really engaging. But they're also solving for what time should these two things intersect and where should they intersect. And I don't know if you looked at my picture here, but I've put a little X there as to the expected solution for where these two should in fact crash together, and it's really satisfying for me as a math person and as a person who's doing a little bit of coding with this. It's satisfying to me to see that happen, but it's even more gratifying for students. They just get so thrilled that, oh my gosh, we predicted it at the right exact time, and it hit at the exact time that we expected it to hit, and it hit in the place where we expected it to hit. And so this math problem that we've all solved, two trains leave a station and when do they pass, actually does happen in the real world here, and students can kind of put their hands on it in a tangible way, and code rovers and see rovers doing this. Now, these two activities that I've demonstrated here tonight are going to be kind of more in the realm of download a program and run it, but there's certainly things that students could code and you could kind of explore in a coding fashion as well in your math classes. Certainly something to kind of play with and see. I want to pick up, I have like a minute and a half left, and so I want to pick up one more thing, Mike, is that all right, before I turn the ball back over to you?
Absolutely.
All right, fantastic. So I want to go back to kind of Becky's programs here that she had going, just kind of those math applications and the quadratic formula and some of these others. And I'll pull up just one of these here. Maybe we'll make it the area formula. That's the fastest one to look at. So, in this program, Becky has got us looking at the area formulas, making a decision, and then displaying the output. On TI-84, I wanted to kind of give one more little, just a helpful hint. Oftentimes when students are using the displays and kind of, trying to display values from some calculation that they've done in a program, a lot of times that can get lost in translation when they've got text on one side of the screen and the value of a variable displaying on another side of a screen. So there's a nice quick way. It works nicely on Inspire CX to just drop in those commas and everything displays all nice in a row. On CE, we've got a solution for that also. So as you add in the display piece, if you want to display the value of a variable next to it, you use that text and you just bring the two pieces together using a plus sign, and then this command called toString. It takes the value of a variable, evaluates it, turns it into a string, and then you can attach them together. So you'll notice when I run this program using the new feature Alpha F5. By the way, I don't know if any of you saw that little breadcrumb up there in the corner up in the top. Let me hit clear to get out of this menu real quick. And you'll see this breadcrumb up here, edit menu. So this is a new feature of the 84 plus CE operating system that we just updated to 5.3. So Alpha F5 will pop up here and give me, I can execute the program, I can copy and cut and paste. So program editing on the handheld is kind of nice now, really nice new features for doing that. But you'll notice if I ask for the length and the width of a rectangle really fast, I can get that area to display all on the same line by using that toString command. So I just wanted to put that out there as another helpful tip for how to kind of display some of the things that we've shown you how to calculate and how to program on your TI calculators. So with that, Mike, I think you can take the control back, or I can give it back to you. I guess that's probably a better plan. So let me give you the control back and let you go from here.
Thanks so much, Curtis and Becky. As we begin to wrap things up tonight, if you have any last-minute questions for Curtis or Becky, please try to get those asked. I know they'll do their best to get those answered, even though we only have a couple minutes left. I do want to share, go ahead, sorry, Becky.
Well, I noticed somebody has asked the price for Rover. A couple of the places that we normally order from don't have their pricing guides out yet, but they told me that they would have those out in the next couple of weeks. I don't know if that's helpful or not. I just, a couple of places that we usually order from, I've called and I said, hey, there's this new technology. Can you tell me what it's going to cost? And they're getting back to me, and yes, they're carrying them. They just don't have them up yet. I don't know if Curtis knows anything more about that.
I think that's a great answer, Becky.
Thanks so much, Becky. So if you visit our website, education.ti.com, the first pop-up is the TI-Innovator Rover. And so if you click on your Ride Is Here, there's lots of great information, some of which was shared tonight. I know someone was just asking about a video. The videos that Curtis and Becky shared are going to be available to you. They're not. I don't believe so. Curtis, you could verify that?
I hadn't planned on sharing them out, mostly just as a part of this webinar. If somebody wants those things, well, I can probably share them somehow. I'll have to check that out.
Oh, you want like the videos themselves? The webinar itself is going to be archived, right?
Correct, and also recorded and shared. Yep.
Okay.
And you know, there's certainly a video right here, and so there's definitely lots of great information that's available on our website already, and I'm sure that as time goes on, more information will be certainly added.
Somebody just asked, is that the TI-84, does it have the same programming capabilities as the 84CE? They're very similar. There's a few differences, but they're very similar.
Thanks, Becky. So earlier, Becky mentioned about the T-Cubed International Conference coming to San Antonio in early March this year. We're really excited, especially tonight, especially because, you know, for a lot of you, this is probably your first look at the TI-Innovator Rover, and I would bet a lot of money that the TI-Innovator Rover will be at the T-Cubed International Conference this year. So it'll be a great place for you to learn more about it, get your hands on it, do some coding, and see how it really works, and you actually put your hands on it. So please feel free to join us at the T-Cubed International Conference this year to learn more about the TI-Innovator Rover, as well as all of our other products, and just make connections with other educators as well. Also, we mentioned that to one lucky winner tonight, we're giving away a conference registration to the T-Cubed International Conference this year, and tonight's lucky winner is Stacy Dalton. So Stacy, congratulations. We'll be in touch over email in the next few days to give you a little more information, but we hope to see Stacy as well as everyone else at the T-Cubed International Conference. To receive a certificate of attendance, go ahead and click the link in the chat window. Also listed is a link for the documents that were used tonight. The documents link, as Curtis mentioned, the current link, you're only going to get a couple of the documents that were used. That's going to be updated over the next 24, 48 hours. You'll automatically be getting a follow-up email within a few days. So in case your links aren't working tonight, don't worry, you'll, again, automatically get a follow-up email. The nice thing about the follow-up email is the documents link in the follow-up email is going to contain all of the files that both Curtis and Becky used tonight. So all of those coding files, both for the TI-Nspire and the TI-84CE platforms, are going to be included. So it might be worth holding off for a couple of days and just waiting for that email. Thanks so much, Curtis and Becky, for everything you shared tonight. It was really exciting to see the rover in action specifically, and I think we got a lot of people that are excited about how they might use this in their classroom. So thanks so much for everything you shared tonight.
You're welcome. I was excited to do it.
Thanks. I hope you guys have some great coding adventures with your students.
And before we leave, if anyone is interested in being part of our customer feedback team, I'm going to be posting a link in the chat window. Feel free to use that link to give us a little more information about yourself, and there's a chance you might be selected to be part of our customer feedback team, specifically for the TI-Innovator Rover. So, Curtis, is there anything else you want to mention about that, or did I cover that?
No, I think you did a perfect job. We're looking forward to seeing several people fill out that form.
Great. Again, thanks so much, everyone, for joining us tonight. We hope to see you back online next week. Have a great night.